welcome to the course on blockchains, architecture, design and protocols. We are discussing about different use cases as well as the research topics on blockchain. So, today we will touch upon another interesting use case of blockchain and the research topics and aspects around that. The use of blockchain for data analytics. So, how can you utilize the concept of blockchain technology for effective data analytics under various environment with the help of blockchain. So, we will take 2 lectures on that. So, in this first lecture we will discuss about blockchain and its application over big data technology. So, let us look into what is mean by big data. So, big data, it is classified or it is identified by 3 V's, 3 parameters: volume, velocity and variety. So, the volume, the first parameter, it denotes the data size, the amount of data that we have. So, if you just think about a typical data center like say YouTube data center or Google data center, the Amazon data center, in any of these data center, the amount of data which is being generated, it is in the order of trillion of bytes. So, the question comes that how will you manage this huge amount of data. Another interesting example is the social networking sites like Facebook. Just think of the amount of data which is generated from Facebook every day. It is even in the order of few hundred terabytes if I assume correctly. So, that way managing this huge amount of data and running application on top of this huge amount of data is a challenging task. So, the question comes that with this huge amount of data, how can you design effective mechanism or effective algorithm to process the data? Then the second perspective of big data technology is the velocity of the data, like the speed of change of data. Again, think of the example of a social networking website like Facebook. So, the amount of change of data, it is again in a larger scale. Say for example, if you just think about the data which is being generated from a personal profile, personal Facebook profile, it again changes possibly in every day. Another interesting example is the video streaming websites like YouTube. So, you can just think of that every day people are uploading data in YouTube, and the way this data is changing and the information is changing, that is tremendous. So, if you want to do some analytics on top of this streaming media data, if you have done certain analytics today, again you have to run the analytics on the next day and day after to find out a correct result of that or to predict the trend of change. So, this velocity of the data is the second important aspect, and the third important aspect which is again crucial for applying blockchain for big data application is the variety of data. So, the variety of data means say just think of a kind of geospatial application. Say you want to throw a geospatial query. Now, if you want to throw a geospatial query, you have to possibly require data from land registry, you possibly require the imaging data from ISRO, you possibly require the meteorological data, the weather data. So, different varieties of data which are there altogether, and your query need to be executed on top of that variety of data. So, this gives a challenge, this gives multiple challenges for developing an application over the big data platform. So, the question comes not only in terms of query processing or analyzing the data, rather managing the data, sharing the data among multiple peers and then analyzing the data. How will you handle all these things in an effective way? So, we will first look into that what are our challenges for managing this kind of data in a traditional platform that we are using nowadays. So, we will identify certain problems from there, and then we will look into that how we can design a solution for those problems with the help of the blockchain technology. So, let us look into the traditional way of processing big data. So, this volume of data that started increased after internet become global and every people started having a personal computer and then a smartphone through which people are generating data every day. In the early and mid 2000s, people have started thinking about that what type of technology or platform we should require to handle big data aspects. So, multiple technologies were developed such as Zookeeper at Yahoo, then Bigtable and MapReduce platform at Google. Then Cassandra at Facebook. So, all these different kind of technologies that was for developing applications or developing analytical method over big data platform, or developing methodologies to effectively analyze data in a time sensitive way. So, if you want to process a trillion of petabytes of data, then time is a huge constraint. So, if you just run a single processing machine with some fixed amount of RAM and processor power, it will possibly take some even millions of years to process your data. So, that is why people are exploring the technology for parallel processing through MPI based techniques or different kind of techniques through which you can optimize the processing over the big data technology. Then came different kind of open source project like this Hadoop distributed file systems, which was there for handling which was there for storing big data in a decentralized platform. So, storing big data is again a challenge, because you have this huge amount of data, how will you effectively store the data in a platform and how will you access it. So, we require some kind of specialized file system to make distributed storage of data, because a central storage or a single storage is not sufficient to store the entire component of this data which is available. So, that is why people design this kind of distributed storage architecture, where data is stored into multiple storage environment, multiple storage platforms through network attached storage, NAS or storage area network, SAN, this different kind of distributed storage platform. And then this Hadoop distributed file system, it helps in effective access of the data over this kind of distributed platform. And then came this Hadoop MapReduce, which is again an open source project, and Hadoop MapReduce, it helped in executing query effectively on a HDFS kind of platform by optimizing the query processing time, by combining the data, by clustering the data into multiple groups, and then processing the query on the target groups which are interest for the end user. So, that way we witness different such technologies for processing big data, but then comes that what are our challenges for handling big data in a large scale platform. So, the first challenge that we bother about is that who will control the infrastructure when there are multiple actors involved. So, just think of the example of geospatial data that I have mentioned. So, this geospatial data, if you want to execute certain geospatial query, the data is shared among multiple government and private agencies. There are multiple stakeholders who hold the data of different types, and all those different type of data is required to process a geospatial query. So, for example, you want to find out for a specific location, say what is the possibility of having a flood in Mumbai say during April 2018. If you want to have this kind of query over a big data platform, then you require multiple data. First of all, you require the meteorological data, you require the weather data, you require the land usage data, you will possibly require the data from the marine department, the sea level and all these things. So, you require data from multiple such sources and then execute your query on top of that data to find out the result. Now, interestingly, this different type of data are having in the hand of different agencies or different stakeholders. For example, the weather data is there in the weather department, the meteorological department contains their set of data, the marine department contains the sea level data, the land registry record contains the land registry data, then the municipality contains the data of this water disposal and all these individual things. So, that way multiple such stakeholders contain different piece of data, and for this effective processing you require the data from multiple stakeholders. So, the question comes that with this kind of geospatial data, where the data is shared among multiple government and private agencies like say ISRO, DRDO, Meteorological Department, Land Registry Department and so on, who will take charge of the data. Say whenever I am taking data from Meteorological Department and I am trying to combine it with some imaging data from ISRO, then if there is a data loss or if there is some kind of fraudulent behavior from my side, then who will take charge of that, whether that is because of certain problem, certain security loophole for the data sharing platform of the Meteorological Department or certain loophole for the data sharing platform from the ISRO. So, that is a major challenge. So, the first thing. The second thing is that if you have multiple copies of data at different locations, how will you know which one is the most updated data? So, for example, from the ISRO imaging data you can get information about the land usage. From the land registry record you can also get the information about the land usage. How will you know which data is most trustworthy or most recent data? So, that is the challenge related to developing a data sharing platform or data sharing infrastructure, that who will have the control over the infrastructure when there are such multiple stakeholders. The second problem that we have is that how well can you trust the data. So, whatever data you are getting, whether that data is trustworthy or not. So, you have possibly generated the data yourself. How will you prove that you are the originator of the data or you are the authorized person to share that data? Or for example, if you are getting certain data from some agencies or some stakeholders, how will you ensure or how will you verify that he is the authorized person to share the data with you or not? So, these are the kind of important questions, otherwise there can be serious copyright violation and you can be in a big trouble for that. So, to solve this problem, to handle this problem, you have to think of a mechanism to maintain this kind of cooperative relationship among multiple stakeholders or multiple actors. Another problem comes that how will you handle crash and malicious behavior during data transfer from the source. So, whenever you are getting the data from ISRO, it is coming over the network. If certain malicious behavior happens or if someone makes some changes in the data, how will you ensure that that changes have not been done by ISRO or have been done by some malicious agents? Or it may also happen that possibly ISRO has shared the data with another agency and they have authorized that agency to share the data further with you and you are getting the data. How will you detect that that intermediate agency who is sharing the ISRO data with you, maybe with the consent of ISRO, but they have not done any modification on that data? So, the trustworthiness of the data is a major requirement which we need to ensure. The third requirement is that how will you monetize the data? How do you monetize the data? So, the question comes that how do you transfer the rights of the data? Say for example, whenever you are sharing your data with a third party, how will you transfer the right to that third party? How will you ensure that that third party should not share that data with anyone else, or they should share the data under some say control policies. So, that is one important question, and another question which is actually currently floating in the big data community, that can we develop a universal data marketplace, just like data like electricity or internet. So, everyone can buy electricity or buy internet service and then can participate that. So, data can also be a kind of service, because the way we are generating huge amount of data, and if we get certain data, certain share of that data, we can possibly develop lots of applications and we can possibly utilize it for developing a better nation. So, the question comes that how will you handle this kind of universal data marketplace without having kind of fraudulent or malicious behavior in the environment? Well, let us look into certain use cases and see that how can we effectively solve this kind of problems. So, the first use case that we are going to discuss is the shared control of big data infrastructure. So, just think of a blockchain database rather than a traditional database that we have. So, if you have a blockchain database, that means you have say the multiple copies or multiple infrastructural component which are owned by say different zonal offices, and whatever access is being done on this infrastructure, that is maintained, the log is being maintained inside the blockchain. So, that we are calling as a kind of blockchain database. So, the control of the database infrastructure, it is shared across entities. The entities can be within an enterprise, within a consortium, or across the planet. So, there can be a consortium where multiple private companies can join together and they agree to share data among themselves. So, they have their own infrastructure and those infrastructure need to be connected in a trustworthy way. So, we have an example of this kind of blockchain database which is called BigchainDB. We will look into BigchainDB in little details. So, the advantage here is that the infrastructure can be spread across different locations, still the properties of a database like integrity, consistency, all these things are ensured with the help of a blockchain. So, the blockchain will help that whatever access is being done on top of that database, the transactions are being made, they are consistent and they are tamper proof. So, if you access the data through that blockchain, everyone will be able to validate who has accessed the database, who has accessed that particular say data storage and what type of data has been accessed. Well, let us see a specific use case of this. So, each regional office with its own sysadmin, they control one node of the overall database. So, now we are distributing the database among multiple places. So, the entire database is controlled collectively, but every regional office has their own sysadmin control, and in this architecture the data is still protected even one or two sysadmin goes wrong or a regional office is hacked, because even if a regional office is being hacked, the things are through blockchain, it will not be able to access the infrastructure at the other regional offices. Let us look into a second use case, the audit trails on a data. So, consider a data pipeline, the data is being generated and finally, the data is being utilized. So, the data is being generated from the IoT sensors, then you have some kinesis or event hub and the stream analysis which is taking the data from the IoT sensors and doing some initial streaming analysis on top of that. Then the data is put inside an HDFS storage, then you are applying some say Spark data cleaning mechanism on top of the IoT sensor data, then you are applying certain normalization, Spark normalization on that data. Finally, you are transferring the data to a MongoDB storage, a specific database storage, and then doing the table analysis, throwing the query on top of that data. So, if you consider this data pipeline with the audit trails, we mean that we should have an information that how the data, how a particular piece of data has passed into this individual pipeline who has made that passing and on what time it has passed from one stage of the pipeline to the next stage. So, we can again solve this with the help of a blockchain. So, think of a solution of something like this, that before each data pipeline step starts, you timestamp the input data as follows. So, you create a transaction. So, the transaction is an hash of the data and the corresponding metadata or any other information that you want to add in the transaction. Then the cryptographically sign of the transaction and finally, you write the transaction to a blockchain database. So, whenever you are writing the transaction to a blockchain database, it will automatically timestamp the transaction. So, whenever you are writing the transaction in the blockchain database, you have immutable evidence that you had access to the data at that point of time. So, you are ensuring that you have got the data from the IoT sensors, then at that point of time you have done a stream analytics, and then at the next point of time you have put that data in a HDFS database and so on. So, that way every event which is being happened on top of the data, that is being logged in the form of a transaction inside a blockchain, and with that blockchain the things are tamper proof and you can also do certain verification. So, this can actually answer few of our questions that we asked before. So, first of all, how will you prove that you are the originator of the data? So, that was one of our original questions. So, to prove that you are the originator of the data, say your data is cryptographically signed by you and stored in the immutable database. So, that way anyone can use your public key to verify that you are the originator of the data, because that information is already there in the blockchain and the blockchain is tamper proof. Then the second thing is that what about crashes and the malicious behaviors that we are talking about. So, if there is certain kind of crash or malicious behavior, what you can do, whatever data you are getting from the source, from the data source, you rehash the data and check with the information from the blockchain that is there. So, if there is a match, that means you got the correct copy of the data, you can do a validation. If there is a mismatch, that means something is wrong somewhere. So, that means the data that you have got, possibly it is not the correct copy of the data, or someone else has tried to forge that data. Okay. So, with these two use case, let us look into a practical blockchain database, open source blockchain database that I will say, which is there in place and it is gaining popularity for big data application. So, it is called BigchainDB. So, I suggest all of you to explore BigchainDB in more details and do a analysis of its content, its code, and how you can write application on top of BigchainDB. So, BigchainDB has the following features. First of all, decentralization. So, you do not have any single point of control. So, there is no single point of failure. The second is the query. So, you can write and run any MongoDB query over the database. So, it supports the MongoDB query format. The third property is immutability. So, once the data is stored in the database, that data cannot be changed or deleted. So, that data is immutable. The fourth is it is Byzantine fault tolerant, that is an important property of BigchainDB. So, it support and this Byzantine fault tolerant property is to support this infrastructure decentralization. So, based on the BF2 principle, as we discussed earlier, it can support up to 1/3 of the nodes, 1/3 of the nodes in the network that can experience arbitrary failures. So, even if there is 1/3 of the node, at most 1/3 of the nodes experience arbitrary failures, the system will still be able to recover and will be able to give you the correct result. The fifth one is the low latency. So, the transactions finality happens fast because of this Byzantine fault tolerant consensus algorithm which is there. The next one is the customizable. So, you can design your own private network with the help of certain infrastructure and then installing BigchainDB on top of these multiple machines and then connecting them with each other. and then it has a rich permissioning support that you can set permissions at the transaction level. So, you can specify that this particular transaction should be accessible by this person or this group of persons and no one else in the universe. So, it supports a good support of access control list or access control mechanism. So, as I mentioned that this BigchainDB provides a decentralized ecosystem for big data applications. So, you can write the application of your standard big data processing using MongoDB. Then you have this platform which is again a decentralized platform. You can have multiple data servers where the this BigchainDB is installed and they can connect it with each other just like a peer to peer architecture. It supports the decentralized processing of the business logic, like whenever you are throwing the query, it will take care of that in which particular data source the data is there and it will access it and perform the query. And at the lower end in the stack, you have the decentralized file system to store the file in a decentralized environment, and the BigChain database, BigchainDB database, the blockchain database that we are talking about. So, here is a comparison between typical blockchain architecture and typical database distributed database architecture. Interestingly, BigchainDB combines the properties of blockchain along with distributed database. So, the blockchain supports decentralization, Byzantine fault tolerance, immutability and owner control assets, whereas a typical distributed database, it supports high transaction rate, low latency and indexing and querying unstructured data. BigchainDB actually combines all these features altogether. So, it takes the power of blockchain technology to make a decentralized platform with Byzantine fault tolerance and immutable architecture and these owner controlled assets for a rich permissioning of access control, and it combines it with the features of a typical big data database, distributed database like high transaction rate, low latency and indexing and querying on big data through MapReduce or this kind of architecture, which is supported by MongoDB kind of database, and combines and having a central controlled platform. So, that is something a description of BigchainDB. So, here are some further readings that you can explore. So, there is a white paper from BigchainDB. So, the link is given here. So, I suggest all of you to explore it and find out different properties of BigchainDB and how BigchainDB actually implements it at the code level, combines the feature of database as well as the blockchain technology altogether. And you can also try BigchainDB. So, you can go to their developer platform and in this particular link, all these things are under this www.bigchaindb.com website. So, you can install it, you can create a local cluster of few machines and start implementing your own database and running your own queries. So, just try it out. Hopefully, it will be enjoyable for you. So, thank you all for attending the class. So, in the next class, we will come with another application with certain research aspects of blockchain for data science or data processing applications. So, thank you all.